Okay, your notes for tonight is exponential growth and decay. And so I want you to take good notes, make sure that you write everything down. There's a couple of pictures so you remember that Georgia is better than Auburn, no matter what happened on Saturday. Okay, here's the first example. Make sure that you write this down and star it. Keep it in your notes. All right. More importantly, though, here is the notes, or the main thing that you need to write down for today. We're talking about two things, and that's exponential, or a couple things. The first thing is exponential growth and exponential decay. Exponential growth and exponential decay. And if you look at it, the main formula that you need to write down is this: y equals a parentheses 1 plus r raised to the t power. Okay? So the only difference down here is, this is real important, the only difference is a plus and a minus. Plus for growth and a minus for decay. Okay? Plus for growth and a minus for decay. Obviously that's pretty simple to think that when something's growing, it's plus. If it's decaying, it's going to be a minus. Okay? So this is similar to what we did yesterday, but it is not exactly the same. So don't necessarily put what we did yesterday with what we're doing today. Okay? So this is going to be, what's real important to notice here is that y represents the ending amount, and a represents the beginning amount, r is the rate, and t is the time in years. Okay, so it's like a bank account. If this is the final amount in your bank account, the original amount would be how much you put into the bank account. Okay, r would be the interest rate or whatever that you get out of the account, and t represents, like, that would be the time that you put the money into the account. Okay, let's do a couple examples of those. So first example, the original value of a painting is $1,400, and the value increases by 9% each year. Write an exponential growth function to model this situation, then find the value of the painting in 25 years. So we want to use the exponential growth model, okay? Exponential growth function, all right? We want to plug these values in. This is one value, two values, and then this is the third value that we'll eventually plug in. So here's the first thing we want to look at. Step one, write the exponential growth function for this situation. So we plug in 1,400 here, and 9%. Remember that we got to move the decimal from 9%. We make that equal to 0.09. Okay, and we plug it in right there. So this is the exponential function. And then when we solve it for how much the value would be in 25 years, we are going to plug in 25 for t right here. When we plug in 25 for t, then we solve the problem. The first thing we'll do on our calculator is this: 1.09 to the 25th, and then multiply that answer by 1,400 to get $12,000 and $12,072. Okay, so you can see the painting went up after 25 years, went up a lot. Okay. All right, the next example is going to be one of exponential decay. It says the population of a town is decreasing. That's the first key to know that it's decay, because it's decreasing at a rate of 1% per year. 1% per year. In 2000, there were 1,300 people. Write an exponential decay function to model this situation, then find the population in 2008. So what we're going to do first is step one. We are going to input the original population, right? That's the first population, and this is the rate. 1% is changed. 1% goes to 0.01. Okay? And then the next thing we're going to do is plug in step two. We're going to plug in 8. Why 8? Because it's 8 years from 2008. From 2000 to 2008 is 8 years. Okay? So we're going to plug in 8 and get that basically the population will be 1,200 people after 8 years. Okay? 1,200 people after 8 years. Okay? Here's the next slide that you need to write down. This is what we call compound interest. Okay, so this is another type of exponential. Another type of exponential. Make sure that you write down each one of these different items that are in that are in the equation. So A represents the balance after T years, that's the ending amount again. P is the principal or the original amount. R is the same thing, that's the rate. And then now you have two new things. You have a number of times it's compounded. This is a word that's very important, okay? And we say number of times compounded, okay? And we'll talk about that more in class. And then the last thing is the time in years, okay? So notice that this is very similar. It's almost exactly like the last formula, except now it has an N in the problem. Okay, so the only thing different here is that there's an N. All right, first example here. So example, let's do this one. Write a compound interest function to model each situation, then find the balance after the given number of years. So you've got three things here. $1,000 invested, 3%, and it's compounded quarterly, and it wants to know after 5 years, what's the price going to be after 5 years. So we're going to plug all these things in appropriately. So first we're going to plug in 1,000, that's the beginning amount. Then we're going to plug in 0.03, that's the rate that goes in where the R spot is. 4 is it's compounded quarterly, okay? When something's compounded quarterly, there's 4 quarters in a dollar, so we're going to use 4 in that spot and in that spot, okay? Both spots. And then T, so this is the formula that we'll get out of that. Once we did all this in here, we get 1.0075, and then the last step is we'll find the balance after 5 years. We'll plug in 5 for T, and we work it out. We get 1161.18. So that's how much money we would have after 5 years. Okay, so we started with $1,000 and we end with $1,161.18. Okay, and then the next and last example is that we have $18,000 invested at 4.5% compounded annually for 6 years. So let's plug these in. This is our step one. We're going to plug in 18,000. Compound, when it's a 4.5 interest, it goes there. Compounded annually is 1. So annually will be 1. And then the last thing here, the answer, step 2, we're going to raise it to the 6th power, okay? Because it's after 6 years, and 23,440, okay? One other thing I want you to notice when we talk about compounded is this, okay? When something is compounded, that means that, here's the different words that you'll see, okay? Quarterly, that means 4, okay? Annually, that means 1, all right? You'll see semi-annually, okay? And that's going to mean 2. You'll see daily, okay? Well, that's going to mean 365, okay? You'll see monthly, all right? And that will be equal to 12. And you might see bi-weekly, all right? And bi-weekly, there's 52 weeks in a year, so bi-weekly we would say 26 every 2 weeks, okay? Every 2 weeks. So those are some words you're going to see, mainly quarterly, put a star on that one, annually, daily, and monthly, okay? I would expect to know those 4 problems. So that's your video for tonight. Make sure you take good notes, go through and pause it when you need to, and copy everything down.